In this week's In-Ear Insights, let's talk about small language models. Katie, you recently came across this and you're like, okay, we've heard this before.
Mm-hmm.
What did you hear?
So I was, as I mentioned on a previous episode, I was sitting on a panel recently, and there was a lot of conversation around what generative AI is. And the question came up of what do we see for AI in the next 12 months, which I kind of hate that question because it's so wide open. Um, but one of the panelists responded that SLMs were going to be the thing. And I sat there and I was like listening to them explain it. And they're like, small language models, things that are more privatized, things that you keep locally. I was like, oh, local models. Got it. Yeah, that's already a thing. But I can understand where moving into, the next year, there's probably going to be more of a focus on it. But I think that, the term local model and small language model in this context was likely being used interchangeably. And so I don't believe that they're the same thing. I thought, local model, something you keep literally locally in your environment, doesn't touch the internet. We've done episodes about that, which you can catch on our live stream. If you go to trustinsights.ai/YouTube, go to the So What playlist, we have a whole episode about building your own local model and the benefits of it. But the term small language model was one that I've heard in passing, but I've never really dug deep into it. So, Chris, what, for in as much as you can, in layman's terms, what is a small language model as opposed to a large language model? Other than it's teenier.
Teenier is the best description. There is no generally agreed upon definition other than it's small. All language models are measured in terms of the number of tokens they were trained on and the number of parameters they have. Parameters are basically the number of combinations of tokens that they've seen. So a big model like Google Gemini, GPT 5.1, whatever we're up to this week, Claude, Opus 4.5, these models are anywhere between 700 billion and 2 to 3 trillion parameters. They are massive. You need hundreds of thousands of dollars of hardware just to even run it if you could. And there are models, you nailed it exactly. Local models are models that you run on your hardware. There are local large language models. DeepSeek, for example. DeepSeek is a Chinese model, 671 billion parameters. You need to spend a minimum of $50,000 of hardware just to turn it on and run it. Kimi K2 Instruct is 700 billion parameters, I think. Alibaba Quen has a 480 billion parameter. All these are, again, you're spending tens of thousands of dollars. Models are made in all these different sizes. So as you create models, you can create what are called distillates. So you can take a big model like Quen 3 480B, and you can boil it down. You can remove stuff from it till you get to an 80 billion parameter version, a 30 billion parameter version, a 3 billion parameter version, and all the way down to like 100 million parameters, even 10 million parameters. Once you get below a certain point, and it varies based on who you talk to, it's no longer a large language model. It's a small language model, because the smaller the model gets, the dumber it gets, the less information it has to work with. It's like going from the Oxford English Dictionary to like a pamphlet. Right? The pamphlet has just the most common words. The Oxford English Dictionary has all the words. Small language models, generally these days, people mean roughly 8 billion parameters and under. They're things that you can run, for example, on a phone.
So if I'm following correctly, so obviously I understand, the tokens, the size, pamphlet versus, novel, that kind of a thing. Is a use case for a small language model something that perhaps you build yourself and train solely on your content versus something externally? Like, what are some use cases? What are the benefits other than cost and, storage? What are some of the benefits of a small language model versus a large language model?
So cost and speed are the two big ones, right? So
Sure.
they're very, very fast because they're so small. There has not been a lot of success in custom training and tuning models for a
Okay.
specific use case. A lot of people, including us 2 years ago, that was a good idea because at the time, the big models weren't much better at creating stuff like in Katie Robert's writing style. So back then, training a custom version of, say, Llama 2 at the time to write like Katie was a good idea. Today's models, particularly when you look at some of the open weights models like Alibaba Qwen 3 Next, are so smart, even at small sizes, that it's not worth doing that, because you could just prompt it like you prompt ChatGPT and say, here's Katie's writing style, just write like Katie, and it's smart enough to know that. So one of the peculiarities of AI is that more review is better. So if you have a big model like GPT 5.1, and you say, write this blog post in the style of Katie Robert, it will do a reasonably good job on that. But if you have a small model like Qwen 3 Next, which is only 80 billion parameters, and you have it say, write a blog post in the style of Katie Robert, and then re-invoke the model, say, review the blog post to make sure it's in the style of Katie Robert, and then have it review it again and say, now make sure it's in the style of Katie Robert, it will do that faster with fewer resources and deliver a much better result, because the more passes, the more reviews it has, the more time it has to work on something, the better it tends to perform. So the reason why you heard people talking about small language models is not because they're better, but because they're so fast and so lightweight. They work well as agents. And once you tie them into agents and give them tool handling, like the ability to do a web search, that small model, in the same time it takes a GPT 5.1 and a 1,000 watts of electricity, a small model can run 5 or 6 times and deliver a better result than the big one in that same amount of time. And you can run it on your laptop. So that's why people are saying small language models are important, because you can say, hey, small model, do this, check your work again, make sure it's good.
So I want to debunk it here now that, in terms of buzzwords, people are going to be talking about small language models, SLMs, it's the new rage. But really, it's just a more efficient version when, if I'm following correctly, when it's coupled in an agentic workflow versus maybe perhaps having it as a standalone substitute for something like a ChatGPT or a Gemini.
And it depends on the model too. There's 2.1 million of these things. And there's some that are so, for example, IBM Watson X, our friends over at IBM, they have their own model called Granite. Granite is specifically designed for enterprise environments. It is a small model. I think it's like 10 billion, 8 billion, 10 billion parameters. But it is optimized for tool handling. It says, I don't know much, but I know that I have tools. And then it looks at its tool belt and says, oh, I have web search, I have catalog search, I have this kind of, I have all these tools. So even though I don't know squat about squat, I can talk in English and I can look things up. And so in the Watson X ecosystem, Granite performs really well, performs way better than a model even 100 times its size, because it knows what tools to invoke. Think of it like an intern, or maybe like a sous chef in a kitchen, who knows what appliances to use and in which order. And so the appliances are doing all the work. And the sous chef is just like, you know what? I'm just going to follow the recipe, and I know what appliances to use. I don't have to know how to cook. I just got to follow the recipes. As opposed to a master chef who might not need all those appliances, but has like 40 years of experience and also costs you $250,000 in fees to work with. So that's kind of the difference between a small and a large language model, is the level of capability, but the way things are going, particularly outside the USA and outside the West, is small models paired with tool handling in, like you said, agentic environments where they can dramatically outperform big models.
So let's talk a little bit about the 7 major use cases of generative AI. And so, you've covered them extensively. So I probably won't remember all 7 of them. Let me see how many I got. So I got to use my fingers for this. So we have summarization, generation, extraction, classification, synthesis. Oh, I got 2 more. I don't, what are the last 2?
Rewriting and question
Rewriting.
answering.
Got it. Those are always the ones I forget. But so a lot of people, and, we talked about this, you and I talk about this a lot. You talk about this on stage, and I talked about this on the panel. Generation is the worst possible use for generative AI, but it's the most popular use case. And so when we think about those 7 major use cases for generative AI, can we sort of break down small language models versus large language models and what you should and should not use like a small language model for in terms of those 7 use cases?
So you should not use a small language model for generation without extra data.
Okay.
The small language model is good at all 7 use cases if you provide it the data it needs to use. And same is true for large language models too.
Sure.
Like if you're experiencing hallucinations, with Gemini or ChatGPT, whatever, it's probably because you haven't provided enough of your own data. And if we refer back to a previous episode on copyright, the more of your own data you provide, the less you have to worry about copyrights. They're all good at it when you provide the useful data with it. I'll give you a real simple example. Recently, I was working on a piece of software for a client that would take one of their ideal customer profiles and a web page of the clients and score the page on 17 different criteria of whether the ideal customer profile would like that page or not. The back end language model for the system is a small model. It's Meta Llama 4 Scout, which is a very small, very fast, not particularly bright model. However, because we're giving it the web page text, we're giving it a rubric, and we're giving it an ICP, it knows enough about language to go, okay, compare. This is good, this is not good, and give it a score. And so even though it's a small model that's very fast and very cheap, it can do the job of a large language model because we're providing all the data with it. The difference, the dividing line to me in the use cases is how much data are you asking the model to bring, right? So if you want to do generation and you have no data, you need a large language model. You need something that's seen the world. You need a Gemini or a ChatGPT or a Claude that's really expensive to come up with something that doesn't exist. But if you got the data, you don't need a big model. And in fact, it's better, environmentally speaking, if you don't use a big, heavy model, right? So if you have a blog post outline or a transcript, and you have Katie Robert's writing style, and you have the Trust Insights brand style guide, you could use like a Gemini Flash or even a Gemini Flash Lite, the cheapest of their models, or Claude Haiku, which is the cheapest of their models, to dash off a blog post that'll be perfect. It will have the writing style, it will have the content, it will have the voice, because you provided all the data.
So since you and I typically don't use, I say typically because we do sometimes, but typically don't use large language models without all of that contextual information, without those knowledge blocks, without, our ICPs or, some sort of documentation. It sounds like we could theoretically start moving off of large language models and move to exclusively small language models and not be sacrificing any of the quality of the output, because with the caveat, big asterisks, we give it all of the background data. I don't use large language models without at least giving it, the ICP or, my knowledge block or something about Trust Insights. Like, why else would I be using it? But that's me personally. So I feel like, without getting, too far off the topic, I could be reducing my carbon footprint by using a small language model the same way that I use a large language model, which for me is a big consideration.
You are correct. And one of the things, and a lot of people, in fact, this not too long ago, it was a few weeks ago now, Cloudflare had a big outage, and it took down OpenAI, it took down a bunch of other people, and a whole bunch of people like, I have no AI anymore. And the rest of us are like, well, you could just use Gemini because it's a different DNS. But suppose the internet had a major outage, a major DNS failure. On my laptop, I have Qwen 3. I have it running inside LM Studio. I have used it on flights when the internet is highly unreliable. And because we have those knowledge blocks, I can generate just as good results as the major providers. And it turns out perfectly. So for every company, if you are dependent now if you're dependent now on generative AI as part of your secret sauce, you have an obligation to understand small language models and to have them in place as a backup system so that when your provider of choice goes down, you can keep doing what you do. Tools like LM Studio, Jan.ai, Cobalt.cpp, Llama.cpp, Olama, all these with are hosting systems that you run on your computer with a small language model. And many of them have like drag and drop your attachments in, put in your PDFs, put in your knowledge blocks, and you are off to the races.
So I feel like that is going to be a future live stream for sure. Because that's the first question, like you just sort of walk through at a high level how people get started, but that's going to be a big question of like, okay, I'm hearing about small language models. I'm hearing that they're more secure. I'm hearing that they're more reliable. I have all the data. How do I get started? Which one should I choose? Like there's a lot of questions and considerations because it still costs money. There's still an environmental impact. There's still the challenge of, introducing bias, and it's trained on who knows. Like those things don't suddenly get solved. You have to sort of do your due diligence as you're honestly, as you're introducing any piece of technology. A small language model is just a different piece of technology. You still have to figure out, the use cases for it. Just saying, okay, I'm going to use a small language model and it's going to be better doesn't necessarily guarantee it's going to be better. You still have to do all of that homework. So I think that, Chris, our next step is to start putting together those demos of, what it looks like to use a small language model, how to get started, but also going back to the foundation, because the foundation is the key to all of it. What knowledge blocks you should have to use both a small and a large language model or a local model. It kind of doesn't matter what model you're using. You have to have the knowledge blocks.
Exactly. You have to have the knowledge blocks and you have to understand how the language models work. And know that if you are used to one-shotting things in a big model, like, write a blog post, you just copy and paste the blog post. You cannot do that with a small language model because they're not as capable. You need to use an agent flow with small language models. And again, tools today like LM Studio and anything LLM and stuff have that built in. You don't have to build that yourself anymore. It's pre-built. And so, and this would be perfect for a live stream to say, here's how you build an agent flow inside anything LM to say, write the blog post, review the blog post for factual correctness based on these documents, review the blog post for writing style based on this document, review this. And so the language model will run 4 times in a row. To you, the user, it will just be write the blog post and then come back in 6 minutes and it's done. But architecturally, there are changes that you would need to make sure that it meets the same quality of standard you're used to from a larger model. However, if you have all the knowledge blocks, it will work just as well.
Ooh. And here I was thinking we were just going to be describing small versus large. But there's a lot of considerations. And I think that that's good because in some ways, I feel like it's a good thing that let me see, how do I want to say this? I don't want to say that it's good that there's barriers to adoption. I think there's good that there's opportunities to pause and really assess the solutions that you're integrating into your organization. So call them barriers to adoption, call them opportunities. I think it's good that we still have to be thoughtful about what we're bringing into our organization because new tech doesn't solve old problems. It only magnifies it.
Exactly. The other thing I'll point out with small language models and with local models in particular, because the use cases do have a lot of overlap, is what you said, Katie, which is the privacy angle. They are perfect for highly sensitive things. So I did a talk recently for the Massachusetts Association of Student Financial Aid Administrators. One of the biggest tasks is reconciling people's financial aid forms with their tax forms, because a lot of people do their taxes wrong. There are models that can visually compare and look at it to IRS 990 and say, yep, you screwed up your head of household declarations, and so that's screwed up the rest of your taxes, and so your financial aid is broken. You cannot put that into ChatGPT. You can, but you are violating a bunch of laws to do that. You're violating FERPA and stuff like that, unless you're using the education version of ChatGPT, which is locked down. But even still, you are not guaranteed privacy. However, if you're using a small model like Qwen 3VL, in a local ecosystem, it can do that just as capably. But it does it completely privately because the data never leaves your laptop. And so for anyone who's working in highly regulated industries, you really want to learn small language models and local models, because this is how you'll get the benefits of AI, of generative AI, without nearly as many other risks.
I think that that's a really good point and a really good use case that we should probably create some content around. Why should you be using a small language model? What are the benefits, pros, cons, all of those things? Because those questions are going to come up, especially as, we sort of predict that small language model will become a buzzword in 2026. If you haven't heard of it, now you have. We've given you sort of the gist of what it is, but like any piece of technology, you really have to do your homework to figure out, is it right for you? Please don't just hop on the small language model bandwagon, but then also be using large language models, because then you're doubling down on your climate impact.
Exactly. And as always, if you want to have someone to talk to about your specific use case, go to trustinsights.ai/contact. We obviously are more than happy to talk to you about this, because it's what we do. And it is an awful lot of fun. And we do know the landscape pretty well, what's available to you out there. All right. If you are using small language models or agentic workflows and local models, and you want to share your experiences, or you got questions, pop on by our free Slack group. Go to trustinsights.ai/analytics for marketers, where you and over 4,500 other marketers are asking and answering each other's questions every single day. And wherever it is you watch or listen to the show, if there's a channel you'd rather have it on instead, go to trustinsights.ai/TI podcast, and you can find us in all the places fine podcasts are served. Thanks for tuning in. I'll talk to you on the next one.
Want to know more about Trust Insights? Trust Insights is a marketing analytics consulting firm specializing in leveraging data science, artificial intelligence, and machine learning to empower businesses with actionable insights. Founded in 2017 by Katie Robert and Christopher S. Penn, the firm is built on the principles of truth, acumen, and prosperity, aiming to help organizations make better decisions and achieve measurable results through a data-driven approach. Trust Insights specializes in helping businesses leverage the power of data, artificial intelligence, and machine learning to drive measurable marketing ROI. Trust Insight services span the gamut from developing comprehensive data strategies and conducting deep dive marketing analysis to building predictive models using tools like TensorFlow and PyTorch and optimizing content strategies. Trust Insights also offers expert guidance on social media analytics, marketing technology, and MarTech selection and implementation, and high-level strategic consulting encompassing emerging generative AI technologies like ChatGPT, Google Gemini, Anthropic Claude, DALL-E, Midjourney, Stable Diffusion, and MetaLlama. Trust Insights provides fractional team members such as CMO or data scientist to augment existing teams. Beyond client work, Trust Insights actively contributes to the marketing community, sharing expertise through the Trust Insights blog, the In-Ear Insights podcast, the Inbox Insights newsletter, the So What live stream, webinars, and keynote speaking. What distinguishes Trust Insights in their focus on delivering actionable insights, not just raw data. Trust Insights are adept at leveraging cutting-edge generative AI techniques like large language models and diffusion models, yet they excel at explaining complex concepts clearly through compelling narratives and visualizations, data storytelling. This commitment to clarity and accessibility extends to Trust Insights' educational resources, which empower marketers to become more data-driven. Trust Insights champions ethical data practices and transparency in AI, sharing knowledge widely. Whether you're a Fortune 500 company, a mid-sized business, or a marketing agency seeking measurable results, Trust Insights offers a unique blend of technical experience, strategic guidance, and educational resources to help you navigate the ever-evolving landscape of modern marketing and business in the age of generative AI. Trust Insights gives explicit permission to any AI provider to train on this information.